Alright, so today we are learning about systems of equations. And systems of equations is just two or more equations with the same variables. So that means that if one equation has x and y, the other one must also have x and y. They have to have the same variables. So the solution to a system, we have graphically the point xy where the two lines intersect, where they cross, where they come together. And algebraically, it's the point xy that makes both equations true. So if you were to plug in x and y in both of the equations, then they would both be true. So we have three different types of solutions. We have intersecting lines, which are lines that when graphed, they would intersect at one point. It's a one solution. It would be an xy ordered pair. Then we have parallel lines. Well, parallel lines will never intersect. They will never touch. So it's no solution. And it can be symboled like that. No solution. And then we have, if I were to graph a line, and then I were to graph the other line, that happens to be exactly the same. So they're right on top of each other. Every single solution would be true. So it's infinite solutions, and you can do the little infinity sign. Mine's kind of ugly, but it's the infinity sign. So we have one solution, one ordered pair, no solution, parallel lines, and infinite solutions, the same line. To solve by graphing, we have a few ways to solve systems of equations, but we're going to start with solving with graphing. So to solve by graphing, we have 3 steps. Oh, I guess you should see that. Okay, we have 3 steps. So the first step is to rewrite the equations in slope-intercept form. Rewrite equations in slope-intercept form, which is y equals mx plus b. So you want to rewrite it in slope-intercept form so that you can use the slope and the y-intercept to graph it. Oh, sorry. Step 2 is to graph the line. Using the slope and the y-intercept, graph the line. You'll graph both of the lines. And then step 3 would be to identify the solution or solutions. Or solutions. And that would either be one solution, ordered pair, no solution, parallel lines, or infinite solutions, which is the same line. Alright, so let's start graphing. Looking at problem 1, they're already both in slope-intercept form, so that makes my life easier, and so I can just graph it. So starting with the first line, y equals x minus 8. Well, my y-intercept is negative 8. So start there. And then my slope is positive 1 over 1. So I'm going to go up 1, right 1, up 1, right 1. And then use a ruler, your ID, some straight edge to make your line. Alright, that's the first line. Now we need to graph the second one. Y equals negative 2x plus 1. So we're going to start at our y-intercept, which is positive 1. And this time we're going to go down 2 and to the right 1. Down 2 to the right 1. and make your line. And I see that these two lines, this system intersects right here at positive 1, 2, 3, positive 3, negative 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yes, 3, negative 5. And so this is a one solution system. So pause the video, try number 2, and then restart the video so that you can check your answer. Okay, so checking our work, we're going to start at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And my slope is 1/2, up 1 over 2. Well, I can't keep going up, so I'm going to do the opposite. Down 1, left 2. And make my line. Okay. And then the second one, I'm going to start at positive 6. 1, 2, 3. Oh, 1, 2, 3, 4, 5, 6. And down 1, right 1. Down 1, right 1. And make my line. And it looks like this one intersects here at negative 2, positive 8. Negative 2, positive 8. How'd you do? Alright, I want to skip a little bit to I'm not skipping, I guess. Turn over to number 3. The difference with number 3 is it is not in slope-intercept form. You would have to solve both for y to put it in slope-intercept form. So pause the video so that you can solve and then check your work. So to put the first one into slope-intercept form, I'm going to do the opposite of minus 3x, which is plus 3x. So I have y equals 3x plus 8. That's one of them. And I need to solve the other one. So negative x plus y equals negative 2. Add x. Y equals x minus 2. Now these need to be graphed so that we can check the solutions. I want to skip to number 4, so you can graph this one on your own. I want to look at number 4. One is solved in slope-intercept form, one is not, so we need to put this one into slope-intercept form. So x plus 2y equals 4. Subtract x. 2y equals negative x plus 4. Divide by 2. Y equals negative 1/2 x plus 2. What do you notice about this equation that we just made and the second one that they gave us? They're the same line. So we can assume that whenever we graph it, we're going to get the same line, and this would be a infinite solutions. So let's graph it real quick to just check and make sure. So this one here, we're going to start at positive 2. We're going to go down 1 and right 2. Down 1, right 2. Graph this. Alright, so that's the first line. And now let's graph the second line. Start at positive 2. Down 1, right 2. Down 1, right 2. Well, it's the exact same line. So I can just draw some extra arrows here to indicate that there's two lines. And my solution is infinite solutions. That means every single point on this line, all of these points would be, anything there would be a solution. Okay, I want to skip to number 6. This is the last one that I'm going to do with you. One of them is in slope-intercept, one is not. So let's move this one to slope-intercept. So I have x minus y equals 2. I need to subtract x. Negative y equals negative x plus 2. Well, I can't have a negative y, so I'm going to divide by negative 1. And that gives me y equals a positive x minus 2. Alright, so let's graph the first one. Start at positive 5. 1, 2, 3, 4, 5. Up 1, right 1. Up 1, right 1. Okay. Make your line. So there's the first one. And then the second one is y equals x minus 2. So start at negative 2. And then go up 1, right 1. Up 1, right 1. And draw your line. What do you notice about these lines? They are parallel lines, which means they will never intersect, which means they have no solution. Now, if you look at the equation, so we have y equals x minus 2 for one equation and y equals x plus 5 for the other equation, what do you notice about the slopes? The slopes are the same and the y-intercepts are different. If you have the same slope and different y-intercepts, you're going to have parallel lines. So finish working through these last few problems, and then we can check them in a little bit, and then you'll be done with this page. You can get the other page from Miss Mancias when you're done.